This lesson is about measures of spread. Previously, we've looked at measures of central tendency, which were what is a typical value of the data set. So if we look at all our heights in the room, on average, how tall are we? Give me one number that represents the group. Okay, measures of spread is more about how much variation there is in the data. Okay, so measures of spread or variation. In this lesson, we're going to look at two of them. We're going to look at the range and the interquartile range. Okay, this IQR means interquartile range. Okay, the range, imagine we've got a class of people, some really small people, some really big people. The range is simply the difference between this enormous giant here and this tiny midget here. Okay, so whenever we're calculating range, max minus min. Interquartile range is a bit more interesting. Okay, with our data set, okay, so with all the people we've got drawn here, we know that the middle person here is the median. Okay, so to calculate the median, we're basically dividing the data set in two. With quartiles, as the name suggests from the word quarter, we're going to divide the data set into 4 parts. So this first part will be the first quartile, the median is quartile 2, and at about 3/4 through is quartile 3. So these quartiles Q1, Q2, and Q3, we can say 25% of data is below Q1, and we can do the same thing here. So Q2, or for the median, 50% of the data is below Q2, and for 75, correction, for Q3, 75% of the data is below Q3. Okay, so if someone says you're in the first quartile, you'd be like, oh, that's no good. There's 3/4 of the class that are taller than me. So the idea of the interquartile range compared to the range is that instead of, we'll get another color, instead of just comparing these two guys like we did in the range, okay, we're actually going to compare these two guys, people, okay, male or female. So interquartile range is going to be the difference in height, or the difference in the values of Q3 and Q1. Okay, and we'll show you how to calculate them. Why do we care about the IQR? Well, imagine if in our class we suddenly had someone like Yao Ming come along, okay, with an extremely long neck and a normal sized body. Okay, he's going to affect the range significantly. Okay, you can imagine the range is going to increase by how much taller he is than the previous taller person. However, the interquartile range won't change at all because he's in the top 25%. He won't even be considered when we're subtracting these two quartiles. Okay, so the reason why I care about IQR, okay, is that it's not influenced by outliers, okay, as the range is. Okay, so not influenced by outliers, but like the range is. Okay, so we've got some exam data, and we want to look at the range and the interquartile range. So for class A, okay, to calculate the range, it'll just be the maximum minus the minimum. So 10 minus 1 would be 9. Okay, just looking at the biggest and smallest. For the interquartile range, okay, there's a little bit more involved. We first need to find what Q1 and Q3 are. Since we've got individual bits of data, we're going to have to use these two formulas, okay, if we're comfortable with these. Okay, similar to the median formula, need to look at how many scores we have. 6 scores. Okay, so n is even. So in this case, the first quartile, Q1, will be at the n plus 2 on 4th data point, which would be the 6 plus 2 on 4, or the second data point. So I'll go into my data set, and I'll go first, second, there it is. So Q1 is 4. To find Q3, okay, I use the same idea, the second data point, but I count from the right hand side. Okay, so I'll say first, second, there it is. Okay, Q3 equals 4. So my interquartile range will be Q3 minus Q1, interquartile range of 0. Okay, so comparing these two statistics, the range was 9, so we've got some extreme values, but if we just look at the middle 50%, okay, so we get, this would be the middle 50% of the data, we're getting rid of the smallest 25 and the biggest 25, we have an interquartile range of 0. Okay, so we know that that middle 50%, they're pretty homogeneous, okay, pretty similar. I want you to do part B, so press pause and then have a look at the solution. All right, let's see how you guys went. Okay, using the same formula, okay, we ended up getting 1 for the range, the max minus the min. Okay, we had 8 scores, so an even number of scores, so we were using that same formula. End up getting the 2.5th score, so that's between the second and the third scores. Okay, just like we did for median. Okay, so when you're finding Q1 and Q3, it'll just be the average, okay, the mean of those two scores. Okay, the score that's exactly in between them. Okay, obviously we don't want to be doing these manually for our whole life, especially if we're working on the census where we're going to have 24 million people responding to a survey. So I can enter the data into a graphics calculator list, and then remembering my calculator drills, I want to do a calculation, individual data, list and frequency 1, and I'll press this button. Okay, it gives me the stats. Does it give me range and interquartile range? Well, no, not really, but it does give me what Q1 and Q3 are. So Q1 is 4, Q3 is 5. Yep, all good. So I can do my calculation. So if I was instructed to do it on the calculator, I'd get this output, write down what Q1 is, write down what Q3 is, and calculate interquartile range. Similarly for the range, okay, my max is 5, my min is 4. Okay, we will do this activity in class. Okay, where we'll get some tabulated data and we'll try to find the range and the interquartile range at the time taken to travel to school. Okay, we'll see what sort of times it takes you guys to make the trek to school. All right, I think you can probably have a go at. Yeah, I think you can have a go at these first 3 questions. Okay, so do these. Do for Tuesday. We'll do this little activity and then spend a fair bit of time reviewing your diagnostics. Okay, bye.